3. Updating your sensor configuration through the NodeNs Python script. You may also update the sensor using the NodeNs sensor update script. This is a quicker and more lightweight method of updating the sensors, although it doesn't give you the visual feedback of the GUI. So, it's a good idea of updating your sensors if you know exactly what you want to change and you want to do it quickly, or if you want to batch update a few sensors at once. I'll set up and start a clean virtual environment first of all. Now that that's done, the first step is to install the relevant NodeNs script, which is most easily done through pip. The script we'll use for the update is called nodens.update, and you can install it using the command pip install nodens.update. You might also want to run the nodens.gateway script as well, which is installed using pip install nodens.gateway. This will allow you to monitor for changes in the sensors, receive confirmation of config updates, and it's also the script used to communicate with cloud services. There is a separate video which goes through the nodens.gateway features. Just as a note, the reason we have two separate scripts is because they can be used as plugins to connect to external cloud services. So this just makes it a bit easier to do updates while we run the cloud services. I'll now open up a second terminal window, activate the virtual environment, and then start the gateway script we just installed. I'll note that when I start the script, it checks for the relevant configuration file, which is logged with the statement config file found. If you haven't already got one, then the default configuration will be created, which you can then edit. The sensor is currently found at IP address 192.168.0.108, although the default would typically be 10.3.141.1. Leaving this script running and going back to the first terminal window, we now run the nodens.update script. This will look for a sensor update configuration file and use that to update the sensor. I will go through it in detail shortly, but let me just show you what the process looks like. I execute the update script, and then that's it. While it's not strictly necessary to check the gateway script, let's go back to the first terminal to see what's happening. Here, we can see some commands going through to the sensor and then coming back from the sensor. We can wait for the new configuration to load, as the sensor has sent the message waiting for config. And now it's done. We have received the message sensor started. I'll now describe the sensor config update file. The name of the file is config-update.yaml. The file currently has 4 sections. The first is sensor. Here we define the parameters of the sensor and MQTT broker to be updated. root_ID is the address of the root sensor node, which can be found printed on the sensor enclosure. Sensor ID is the address of the sensor to be updated. In this case, they're the same. IP address is the address of the MQTT broker. Sensor port is the port, which is 1883 by default for an unsecured connection, or 8883 for an encrypted connection. Both are supported, but for an encrypted connection, we'll have to provide the secure keys. Data transmits controls Wi-Fi transmission of the data. The radar performs millions of calculations a second and scans to around 20 frames per second, so we have worked to reduce the amount of data the sensor transmits. We obviously don't want to bog down your network traffic. Transmit time is the amount of time between successive transmissions of Wi-Fi data. Depending on application, we may transmit every 2 seconds, every minute, or even less frequently. Full data flag indicates whether we wish to send full diagnostics data, such as point clouds and microdopplers. This will naturally require more transmission bandwidth. Full data time specifies the amount of time between transmission of successive full data packets, and must be greater than or equal to transmit time. Radar specifies the radar scanning configuration. Radar send flag specifies whether a new configuration will be sent to the radar. You might want to switch this off if you're only updating the Wi-Fi transmit time, for example, or if you want to switch full data mode on. But if you want to change the size of the area you're monitoring, then set this value to 1. To set the size of the room you're monitoring, use the room underscore x, y, or z min and max values. The x-axis runs from left to right from the perspective of the sensor. The y-axis runs in the direction the sensor is facing. These should always be positive values as we do not scan behind the sensor. The z-axis runs up and down and floor to ceiling. In this coordinate system, the sensor is located at position xy equals 0, 0. The monitor area is an optional smaller area within the room where occupants are likely to be stationary. This could be a bed, for example, or a waiting area. We specify these as pairs of values, so monitor underscore x would have lower and upper x bounds. The remaining values relate to the sensor positioning. Sensor height is the height of the sensor above ground, i.e. along z. Sensor yaw is the side-to-side rotation. A rotation from plus x to minus x would be given by a positive angle in degrees. Sensor pitch is the downwards tilt. A positive angle in degrees specifies the tilt downwards. The final section is entryways, which can be used to define doorways and other entry points to the monitored zone. These are given as pairs of x and y coordinates. If you're defining more than one entryway, separate the values using semicolons. And that's it. We can now run the NodeNs update script and send it through to the sensor once again.